This week's episodes were brought to you by the generous support of Yukofin. Hey folks, Quilly18 here, and welcome to another episode of our Unity Project MightySpud, where we are trying to make a terrain engine. Right now, we're trying to get the terrain to be level underneath one of these automatically placed buildings here. And what we're ending up with is a spire. Now, the height is because we're forcing it to a height of 1, so that's okay. But we ended the last video with, why is it just this little speck and not in the position that I expected? And I realize there's one, certainly, big math error. It might be the only one. I mean, it's one simple error, but it's probably the source of all the issue. There might be more than that. But what's happening here is I am dividing these various measurements that I've got going on by the height map resolution. That is incorrect. In fact, what I need to be doing is dividing this by the number of world units per map index. What do I mean by that? Well, in this example here, where our world... Ooh, I got it big in this, sorry. Too big, maybe? No, there we go. Where our world is, say, 1,024 units wide, and our resolution value is like 129 currently. The question is how many... Each point in our array, how much distance does it span? In which case, it's going to be a distance of, I don't know, like 8 world units per thing. I guess we could do a quick little 1,024 divided by 129 is 7.93. Oh, I was very close. I was very close. And in fact, that last one doesn't really count. It should actually be divided by 128, I just realized. Almost certainly for the right distance because, hey, let's open up Photoshop. If we go and paste you in there and then switch to our paintbrush and our font says okay. So what we have is a map, right? We have our square map. Hell, I could use this thing, I suppose. Let's just do that. Where each point in the index, right? This is a point in the index here and there and there. This determines where our, how our terrain is generated, right? We have all this up until we get to the end. There's one more point on the end there, but we wouldn't count that in for the distance. We'd just be counting, we're effectively counting the gaps, right? In this case, so it's one less. So we'd have 828 gaps. So, yeah, 1,024 divided by 128 equals a distance of exactly 8 world units per sort of one of these gaps in our index. With those numbers, now, then we may go with different numbers, but, so let me reword this. It's how many array units wide? So, it has a resolution / vertex count of 129, but that means it has a, I don't know, 128, like, edges / squares, whatever, / whatever. Which means, imagine that our structure is at a relative position of, say, let's put to exactly 512 to make our life a little simpler, which means that in this case, it's, so it is, so that means that, so there would be 8 world units per array index. So if our structure is at relative position 512, then 512 divided by 8 equals array position. And let me just verify because I'm being I haven't gone crazy. If we did do something like that, then we certainly get 64. Yeah, okay, good. Because that's what we should be. We should be at the midpoint of this array here. Array index 64. Yes, for the minimum. But for the maximum, we'd probably want to give it the +1, right? Because that's actually a good example. If we go... I see I should have been using my Photoshop before. Why did I forget about Photoshop when I was trying to explain things? Right? Let's say we have our object over here. Here's our structure. And we have our grid... Like we have a grid point here, and therefore here, 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 and here. And so it's very important, and I mean, obviously we, infinite number of x, well, not infinite, but you know what I mean. It's very important that it is these 9 in this example would all have to be raised up to be level. So in this case, if this point here, like, let's say it was exactly flush here. Let's say this was actually our structure. Like that. Let me get the eraser and erase you this way. There we go. So in our little discussion, this point here, call this one 64 on the X, right? Because it's the bottom left corner. That's fine. And it has a width such that it also covers this one over here. But what's important is that when we do our math here, and we do whatever position this is going to be, some number divided by 8, whoops, which would give us a value of something like 65 point, I don't know, to me that looks like a 65.6. Well, this would be an example where we have to round this one up so that we can hit this point over here of 66. And this is going to be fine because the extreme example of if we're at the edge of the map over here, where this vertice right over there is 129, then again, if we had a structure here, we'd be rounding it up. The one case where it would be weird, and we have to use a round up and not a +1, because if we're right on the edge and we're adding a +1, then it would bring us to 130, which would be bad. But as long as we're using a round up, then it'll round up to exactly 29, which might already be its value, but that's going to be okay. So what I'm actually going to do, do I want to rewrite this slightly differently? Because I feel like it's a little bit messier, and we could probably, with a few more variables, hey, a few more variables never hurt, right? Sure. Would it become a little clearer for people? I don't know if it really matters one way or another. But what's important, what the upshot of all this, is that we have some sort of float here, which is actually world units per array index. And I guess one of the things, right now, our maps are square. It's entirely conceivable that we are working with non-square terrain, which means instead of height map resolution, we may, in fact, so we have some number, 0, divided by terrain data, and then it's this width, right? Right over here, height map width and height. In theory, these two values, as well as resolution, are all the same. But it's not actually guaranteed. It is because we're square, so I guess it's probably fine. Assuming I'm remembering these numbers right, but they should be. So what we want is, we want terrain data, dot size, and in here that's a vector, so again we have to put in a direction. So we have to, if we assume it's square, let's say we do this, right? Really this is world units per array index X, and there's another one that's Y. If we assume that we're square, well, it's actually, so this would be the Z component, but then it would be height. If we assume that it's square, these two should be the same, and we can use either one. But that's why I'm wondering, you know what? Let's break it down. Let's break it down. It's going to be fine. So what we want is, we want an int, which is going to be the min x. You know what? I'm going to feel a lot better that way. So what we're actually doing is we're doing the structure position offset.x, but instead of dividing it by the height map resolution, instead of dividing it by 129, or whatever it is, we're at, I guess this should be a -1, right? Yes, it should. Yes, it should, because we're not dividing 1024 by 129, we're dividing it by 128. So we're going to do dat. And then here, so yeah, instead of dividing by 128, we're actually dividing by the 8 over here. So that's going to give us the minimum x value. Well, these are all floats. Yes, but it needs to be an int. So what we need to do is say something like floor int. I mean, we could just cast it as an integer, but we're going to do one of them will be a ceiling to int. In fact, that's exactly what the max x is going to be. So max x is going to be ceiling to integer, so it will round up to an integer. And it's going to be the structure position offset x plus the structure bounds dot size x, and order of operations will dictate that we need parentheses around there, divided by the x. So we've got those two, and then we can do the same thing with the y. So this is actually, again, the z and y. I know we're mixing things, but when we go from a vector 3, the z component is the y component of our array. put a little note here. Okay, Z, Y, Z, Z, oop, Y. There we go. That's why I'm just double checking. So I think we've converted all those. Min Y, max Y over here. We don't need U anymore. And then this loop becomes slightly cleaner because what we can just do is something like this. It starts at min X. X is less than max X, X plus plus. Good. Copy, paste over here, get rid of this note. We're going Y, 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 Y. Okay. Do. Again, these will probably need to be inverted, but I'm going to leave it there for now. Because it feels good when there's an error that happens and you know how to solve it. So sometimes leave solvable errors for yourself. It makes you feel better. I'm going to get rid of these debug comments here as well. Aha! That's exactly what I was expecting. This square is roughly the size, if you did this mouse here, they're roughly the same size. But it's mirrored along the central axis here, or diagonal axis, I guess I could say, which tells us that we need to invert our two little buttons. So I'm going to double click on some of these debug log things and just go and say, comment U. Okay, because I did get U. What else is in here? Oh, these angle diffs. Oh, right, that's part of our structure, which probably, if I recall correctly, we still have this note. I am wrong here. Make math more better, please. I think I know. I think we need to check the difference in longitude between the center of the terrain chunk and where the building is. But again, I'll leave this one as an exercise to the viewer. I think those might be all the debugs that we had left in. Okay, so all we're going to do now in the play structure is invert the Y and X. Invert XY, like that. Or mirror, I suppose I could say it that way. But. Oh, then we actually have to set the height correctly, which we haven't done yet. But that's okay. So now, perfect. Our square, where's our little cool base? If I just click on it, we get to see it. It looks like we are basically encompassed where we're supposed to be. So let's just change the height to be correct at this point, which instead of setting it to Y, what we want to do, and this is actually something we can pre-calculate, is something like float correct height. So what we're going to use is we're going to use the structure game object. I guess, or you could use, I suppose, the lowest bounds. That's actually question. Let's assume we don't want to use the lowest bounds because it's perfectly viable. We might, be lazy with our building construction and end up with like squares and stuff that go like through the bottom. We're going to assume that we're going to use our structure game objects transform.y. Like the parent game object, its y coordinate is going to be the true ground or the base of our structure. Maybe it has a basement and we want that basement to be under the terrain or some damn thing. There's all sorts of possibilities. So we're going to use that, and that's good, but we have to remember this is world space y. First of all, we need and we need to convert this into a value of 0 to 1 based on the height of the of our terrain. So first of all, we want to do something like ry, and this probably doesn't matter, but we're going to go this dot transform dot y. First of all, make sure that we're using dot position dot y. Okay, just in case. Now, as is, all of our terrain should have a y value of 0, but it's not guaranteed. Maybe we've done something stupid somewhere along the way and we don't. So we're going to make sure that we are now working with the same relative numbers. But then we have a relative height in unity space, but this needs to be a value from 0 to 1. So we're going to have to divide it based on this number, which actually is hard-coded in here, which we do not want. I think we want something like public float terrain height. The height of the tallest possible peak in our terrain. And we will set this to 512 by default. And then set that right there. There we go. Now, we could read this. Actually, here's the thing. I was hard-coding it in, and that's not good, but rather than use terrain height directly, what I should actually reference is the terrain data size. Actually, that makes perfect sense. So, because terrain data size.y contains the greatest possible height that we just set. So if we divide this, now we should end up with a value. Express our height as a value from 0 to 1. Technically, if our building was placed somehow weirdly too high up or too low down, we could end up with a negative value or value above 1. This will clamp when we send it over. If we send a value above 1, I think the terrain just ignores it. We'll pass it as is, and if ever something like that comes up, then we could consider if you've ever seen anything weird with the terrain. I don't know how the building would ever be out of whack because we're placing it here, but we're actually placing it at the correct height for the terrain. We figured that out, so I'm not sure because we sample the terrain height. So our building should always be the center point of our building, or rather the center, the position of this game object here. This should always be flush to the ground somewhere. So this should never be out of whack. In fact, what's kind of interesting is this right over here, the value that is returned by this should be the same as the value if we were to simply sample the height in that position. Right? Terrain.sample height at some position. It should come out to exactly the same value, which is fine. Okay, so if we do this with correct height, and I've inverted the mirroring, so if I were to go and hit play, in theory, there should be a nice flat piece of ground underneath our building. What do we think? Hey, there we go. Ooh, hold on. Why are you peeking out? It's hard to tell if it's just a camera weirdness. You know what? No, I think it's good. It looks almost like it sticks out a little bit, but I think that's just the orange border. I think that's exactly what it is. I think we are... I mean, there might be a slight thing. It might be some weirdness with how the collider is calculated. But no, I think it's pretty much level over there, which is nice. All the other angles seem to be perfectly okay. Notice that, like, there's a little bit of extra land over here, but that's because we're not exactly lined up with a... might even look better if we were in a perspective mode. It's because we're not actually lined up with a vertex, right, of our height map. So, oh, hold on. It really looks like we're overlapping there. We might need... Oh, yeah. No, definitely there. Why is that? Why is it? Now, again, annoyingly, why is this a square and this is not a square? Well, it's because we are just sampling the entire bounds of this thing, right? At no point are we trying to tune what we're doing. And probably what that would involve is a series of array casts. Once we've got the bounds, so here, I'll put in a to-do note. We're not going to add that in here, but to do, or fix me, or, something to consider. I can get rid of that note. Now that we have the greater bounds, or actually, maybe inside of this loop. That's actually a good idea. Yeah. To do. Consider doing a raycast here to see if this spot is actually under the building. For irregular or highly diagonal buildings will currently result in an apparent mismatch between the terrain and the building shape. But also, this is more meaningful, I would say, if you end up coming to the same building from a different angle after having wandering the world, the actual terrain chunks might have an inherent rotation going in. That's what's going on over here, right? When we are starting this up, the reason we're seeing the problem is because our terrain chunks are rotated by 45 degrees, right? Let's let that load up again. Right? It's because our terrain chunk is rotated by 45 degrees, but I mean, internally in the engines we're doing this. If we were to go here in our dynamic terrain master, if I open you up, if I recall correctly, I was made sure to do a rot test. If I turn off the rotation test over here, and I hit play, then our terrain won't be rotated at a 45-degree angle, and our building, our building, which has always been square over here, now that the land looks okay because of the way we're generating it. And there is a little bit of an overlap. Like, I must be missing a +1. Because the bottom left is good. It's the top right. We've got an overlap in both ways. So it's actually nice that we did it here because we see it quite clearly. I must be needing a +1 on the maximums. Despite that, I'm doing a ceiling to int. Which seems a little odd. Doesn't it? It feels like it to me. I mean, I could go and add in, a +1. Or add in like a half a unit or something like that. I'm worried that we're going to get an out of bounds somewhere. I mean, but in a sense, what we're looking for is if we did something like this and like that. Oops. No semicolon. F's. There we go. If I did something like that and ran it, it would probably look better, but it doesn't feel right. Because I'm worried about an out of bounds error later on. Oh, it's still doing this. I mean, I guess I could force it to a 1, but... Maybe. What happens if we're close to the edge, though? Wait. Am I thinking on the wrong sides? No, because that's the same as before. This is okay, but then we still have an overhang that way. Why? Z, Y. It's probably a little thing. I don't think I'll stress about it too much. I still felt like the ceiling to end would be sufficient, but it's clearly not. World units per array Y. Terrain data size Z. Height map height -1. I'm sure that's correct. Well, I suppose instead of the +1 here, I mean, and maybe that's it. I mean, I can add a +1 there. That will definitely resolve the issue. That will definitely resolve the issue, but it feels like... Yeah, and actually, that other +1 was really not doing anything significant. This should 100% fix this, but I'm worried that it'll lead to an error later on. But there you go. So now the building is entirely on the elevated ridge, which is good. Although, what I just realized is we should make sure that our paint cliffs has to happen after the structures. Because the structures are creating cliffs. Right? Right. And we want different textures on the cliffs, but this will be a really good example of having that work right. Unless I have to call like a flush or anything on the terrain, I don't remember. No, there we go. Yeah, it's the gray sort of cliff wall. Looks a lot better. Really shadowed there because we don't have any ambient light. I'm not 100% sure that I've... But I must have. I don't know, I should put a little warning in here, like... Caution, there be dragons here with this +1. But I mean, it's clearly required. I don't know. Your mileage may vary. Maybe there's something to figure out. But we have the ground mostly there. There's plenty of issues, like, you know, the diagonal thing, it doesn't look quite right, and it means that the terrain might look slightly different depending on how the angle is. But the raycast should do it. I think we'll leave it as a to-do here, because I really have to wrap up this tutorial, because very, very soon, Let 'em Dare is going to be starting, and that's going to occupy my brain space for at least probably a 2-week period, because I usually tend to, like, start thinking about things pretty heavily a week before, and then a week after I'm burnt, and I tend to do a post-mortem and all that. So I'd really like this wrapped up before Let 'em Dare. So yeah, I think we'll leave some of those to-dos in there. Next episode, I think we will look at the final step, which is going to and from orbit and swapping from our spherical planet in space to the actual terrain engine that we have just constructed. Thank you very much for watching, folks. See you next time. Thank you to all our April Patreon supporters and these Mic Check supporters. We've got Harry Hendel, we've got Yukofin, Snoopy TRB, Tiburon, Pavel Zdanov, Drazion, Gavin Power, Michael McClintock, Aaron Toibson, Greg Mortel, The Not So Evil Engineer, Julien Auger-Lafont, Marisfield Vold, Speedy Savant, Steven Stagger, Valiant Cake Fiend, Jason Yanity, Steven Bonnerman, Kale the Quick, and Neil Blakey Milner, and everyone who's watched, shared, favorited, and subscribed to these videos. Thank you so, so much.